So great, now for any quadratic equation ax square plus bx plus c, I know the roots, I know the meaning of the root. The meaning of the root is at what given value of x does this whole expression become 0, and the general form of the root solution is minus b plus minus root over b square minus 4ac upon 2a. If you have understood where this has come from, great. Even if you haven't, just knowing this final result can also be sufficient for our purposes, especially for test taking issues as such. Knowing the solution is great, like knowing the backstory is great as well, because it helps you with the basic mathematical thinking processes as such, right? So these are the roots. Now let's think about what is this going to tell us about the root. So this part of the story where I have a b square minus 4ac, this is known as the determinant. Why? It is going to determine how the root, it is going to determine whether this root is going to be real or imaginary, or it will be equal to each other. And it's very, very easy. For example, for a given equation, if you find out that b square minus 4ac is equal to 0, that means for in this part of the story, you have the root as alpha and beta minus b plus minus. This whole part becomes 0. So your root 1 alpha is going to be minus b plus 0 by 2a, and your root beta is going to be minus b minus 0 by 2a. Plus 0 minus 0, what difference does it make? That means both the roots are minus b by 2a minus b by 2a, and they are equal to each other. So if the determinant, and what is the determinant? Determinant is nothing but b square minus 4ac. If this expression is equal to 0, you know the roots will be equal to each other, they will be identical to each other, right? So that is part 1 of the story. If I know that this determinant is greater than 1, it is some positive number. Instead of 0, you have some positive number. For any positive number, you will get a square root, right? You might not be able to find the exact value of the square root, but you will have square root of 19, square root of 17, square root of 36 will become 6, which is fine. But even if the number is not a perfect square, you have a 48, you will write square root of 48. So if there is a positive number, you will get something or the other. That means your first root is going to be minus b plus something, let me just call it s, and for the other one it's going to be minus b minus something. That means these two roots are different from each other, because in this expression you have a plus and in this expression you have a negative. So you will have very different values. So the roots are real and distinct. When this was equal to 0, the roots were real and they were equal to each other. Now when this is greater than 1, not even 1, greater than 0, just a positive number, the roots are real as well as distinct. That means they are different from each other. What do I mean by difference? Because one of them is plus s, the other one is minus s. So they are bound to be different, right? And lastly, if I put a negative number here, so I cannot find the square root of a negative number. It is just an impossible task, and we reach in the realm of imaginary numbers, right? We do not want to deal with imaginary numbers at all, because that's not part of our syllabus. But just the basic idea that you can never find the square root of a negative number. Why? Because imagine, what is the square root going to be? If the square root is going to be positive, that means positive into positive, because square means the number into itself. So a positive number into a positive number will always give you a positive number. Or it could be a negative number, but if you take a negative number and multiply it to itself, which is what we mean by the square, minus into minus will give me a plus. So how do I find the square root of negative? Or just take my word for it right now, because then that becomes a separate topic altogether. When the determinant, which means b square minus 4ac, is negative, the roots alpha and beta are imaginary. They do not exist, right? Just know this much and that will be enough for now. Just connecting the same determinant information to the graphical interpretation of the quadratic. I think some quadratic basic graphing was done in the beginning. In case it is not done, this is an example. Right, this is y is equal to x square passing through 0, 0. So this is the most simplest form of the graphical representation of the quadratic equation. This is a quadratic equation. The coefficient of x is 0, constant is 0, simplest form of the quadratic equation, right? So just like so, this is right now passing at 0, 0. That means the function, the value of y is going to be 0 here. That means the root is also 0 and there is only a single root. Right now just connecting the idea of root to the graph. So another example would be for say this story. So 2 and 5 are the roots. This is the quadratic equation and it will look something like this. X minus 2 into x minus 5. This is the quadratic equation. If you put it equal to 0, then you get, when you put x is equal to 2, you get 0. When you put x is equal to 5, you get 0, right? So these are the two roots, maybe alpha and beta if you want to call them, or vice versa. But now notice you have two separate roots. And what is the meaning of the root again? Where the value of the function is 0. When is the function, which is the line or the curve, when is it 0? Whenever it is going to cut the x-axis, it's going to be 0 there, right? So connecting these ideas together, this is what I mean by distinct and real roots. Another situation could be that your graph is floating in the air, it is never cutting the x-axis. That means it is never becoming 0. So the roots, because it is never cutting the x-axis at all, as you can see in the diagram, the roots don't exist, or at least not in the normal number realm. The roots are in this case imaginary, right? So this kind of a diagram, and again we'll cover this in more detail, we'll work with the graphs again. So this is right now just connecting it to the basic determinant conversation we have just had, that when you have the same root, for example, that means the determinant b square minus 4ac was equal to 0. So I'm trying to connect this information to the graphical representation. And I just don't mean 0 or 0, 0. It could also be like this, like passing at 2, 0. So the root is 2 and 2 only. That means both the roots are same. That means the graph is becoming 0 at only one unique point, which is the same point, because I know there are two roots theoretically. So I'm calling it two roots, but there is only a single root. When the determinant is positive, b square minus 4ac is greater than 0, the roots are real. I can see there are two roots as such, and they are distinct, they are separate from each other. In this case, both the roots are at the same point, that means they are the same root. And in this case, you will find that if you ever find a graph like this, or you find a story where b square minus 4ac is less than 0, the graph will have no roots, it will never cut the x-axis, and the roots are going to be imaginary. So for now this should be enough. So now we have the general form of the quadratic equation. We know how to work out the roots using factorization or by splitting the square, or just knowing the final resultant formula for the root, minus b plus minus root over b square minus 4ac upon 2a. So we have a thorough understanding of the fundamentals of quadratic equation. There is one last point, and again all of this will get repeated in the practice session, exercises, in any question, because the ideas will always come up over and over again. This is just a thorough introduction, warm up, foundation building with the basic ideas, so that next time when we do a problem, we know, okay, b square minus 4ac, we already have the discussion in place, we will not need to spend any more time than there. A quick point to notice for the same thing is that if I look at my, let's say go for my basics again, x minus a into x minus b, before even the quadratic journey started, equate it to 0, expand it, what do you get? You get x square in the last term you get an AB, and in the middle term you get minus x into a plus b. Now look at this, and you know just by looking at this expression the roots are a and b. Why? If you make x equal to a, this will become 0. If you make x equal to b, this will become 0. So you know the overall resultant will become 0 at these 2 points. Now notice this, these are the roots, right? So what is this? This is the sum of the roots. And what is this? This is the product of the roots. So this is another way of writing or understanding or interpreting a quadratic equation, that if you know the roots and you want to create a quadratic equation, it is very simple. X square minus x into the sum of the roots plus the product of the roots. So just for example, I say the roots given to you are 2 and 5. Using this form, because it's the same thing, you will write x minus 2 into x minus 5 and come to this, but knowing this and applying it over and over again, I know the quadratic is going to be x square minus x into sum of the roots. Sum of the roots is going to be 7, and plus product of the roots. The product of the roots is going to be 10. So your quadratic is x square minus 7x plus 10. Just a little bit of changing. A is equal to minus 3 and b is equal to 7. So just writing it in the form x square minus x. What is the sum of the roots? Minus 3 plus 7 is going to give you plus 4. So 4x. You can just write it inverted later. X square minus 4x and plus the product of the roots. Product of the roots is going to be minus 3 into 7 minus 21. So this plus will become minus and it will become a minus 21. So x square minus 4x minus 21. That means this is just a different point of view, just same information looking from different angles. Once you have the roots, you can look at the quadratic as x square minus x into sum of the roots, or the coefficient of x is the sum of the roots, and this is the product of the roots. And just for fun, if I say the roots are k, j and dn, k into j plus d into n, it doesn't make a difference to me. I will just follow the form. That is the whole advantage of the general form and the ideas like these, right? X square minus x into kj plus dn. I shouldn't have written a plus here. These are the two roots, kj and dn. And this, and lastly the product of the roots. So k into j into d into n, assuming that d and n are different numbers. And then I can expand it, play with it. That means whatever is the story, I can plug it into my standard form, which is nothing but x square minus sum of the roots and the product of the roots. So let's now connect it to the standard form of the quadratic equation. And in fact, we are done with the key ideas. And then when we do problems, the key ideas will get repeated and we'll see the usual mathematical problem challenges as such, right? Things that teachers use to make the life more difficult and hide this concept behind a couple of layers of language. So ax square plus bx plus c is the standard form, and now I want to connect it to the what we just saw, x square minus x into the sum of the roots plus the product of the roots. So the first thing I noticed that there was no a in the previous story. My general form came out like this: x square minus x into sum plus the product. Right? However you want to write it in short term. There was no coefficient of x square, or it was 1 here. So I want to get rid of the a first of all. So I'll divide the whole thing by a. What will I get? I will get x square. The a will get cancelled. I'll get a b by a, and then x, and then a c by a. Now again, it becomes about comparing this story and this story together. So x square is absolutely fine, but here I had a minus, so let me put a minus here, and here I have the sum. I have a minus here, but in this expression I have a plus. So to compensate for that, I need to put the minus inside and write this as minus b by a of x. So this plus is taken care of. And now I see, okay, x square minus minus, same, something into x, and that is the sum. That means this is the sum of the roots. Sum of the roots is minus b by a. Right? So now I can connect the general form. If somebody writes an equation like this, 5x square plus 2x plus 3, I can very quickly find the sum and the product of the roots. We'll see in a second. So sum is equal to minus b by a. And then I have a plus. Both the stories have a plus, so no problem there. In this story I have a c by a. And in this story I have the product. That means the product is equal to c by a. So if I have an equation like this and I want to find the sum of the roots, what is the sum? Minus b by a. What is b here? 2. So you write minus 2. Why? Because you want minus b and you put the 5. So minus 2 by 5 is going to be the sum of the roots. We haven't found the roots, but I can find the sum of the roots. What is the product going to be? It is a simple c by a. So a simple 3 by 5 would do, and that would be the product of the roots. So stay with the idea, and again you will see that it is getting connected to what you did in day 1 multiplying of the polynomials, because it is still the same theory being played out. You're just going deeper and deeper and then looking at it from different points of view. But for now, or let's say for the foundation purposes of quadratic equations, we have done enough. We should be reasonably warmed up with the core idea and be ready for the exercises. So if you're comfortable with this, move ahead and try out the exercise by yourself, and only after trying it out a couple of times then join the related discussion where we apply these ideas. Right now we have introduced ourselves and noticed these ideas in action. Next will be the application. But this is it for this little journey, exploration journey on the basics of quadratic. I will see you next with the next idea and more problem solving sessions. The journey is quite a bit to go right now. This is it for the day. I'll see you soon.